All right, in this video, we're gonna be learning about continuously compounded interest at an annual rate. So we're gonna be using what's called the PERT formula. This is the formula you're gonna be using if you see that word continuously. Now, one thing about interest is that it's great when it's working for you. It's not so great when it's working against you, but specifically continuously compounded interest, that's the long man's game. That's where you're gonna start to see some significant growth over time, but it takes some time to get the ball rolling. Okay, so the PERT formula is what would just spit out your answer for if you're trying to determine 7 years down the road, how much money would be in an account if you put an investment in. So I'm gonna give you 3 different problems. I got them set up and ready to go for us. You're gonna need a calculator because one of the things that you're gonna be using in the PERT formula is E. E is a mathematical constant. It's approximately about 2.7, but if you see me type it on the calculator real quick, what you're gonna notice is that decimal just keeps on going. So it's about 2.7, but there's a lot more information in that decimal, so we gotta make sure we use the whole decimal, the whole value of E. Okay, so let's go over everything that we have up here. So I'll write it down without all the labels. We're gonna be plugging our information into A equals P E to the power of R times T. So what you're going to want to do is you're going to want to plug E into your calculator. You'll multiply these two values together, and whatever value you get, you're going to take E and put it to that power. Whatever you get from this needs to be multiplied by your principal. Your principal is the amount you started by putting in. So like, let's say you invest $500 into an account and it's going to compound continuously over time. So that $500 is going to grow over time. All right. So principal, how much we put in at the start. E, just a mathematical constant that we use in a couple of different areas of math. R is our rate of interest. So if you're at a 13% rate, then you need to convert 13% into a decimal. So real quick review, 25% converted to a decimal is 0.25. You just take where the decimal would be in that number and move it back to place values to convert from percentages to decimals. Okay, so as long as you can convert from a percentage to a decimal, plugging in your number for R is not difficult at all. And then the last thing we need to plug in is T. Since this is annually, we're going to be putting in time in years. Okay, so let's go with our first example, which we are going to invest $1,000. So $1,000 is going to be invested. It's going to grow at, let's go an interest rate annually of 5%. And we want to know 5 years later, how much money is that $1,000 grown to, right? If I'm investing it, I expect to have more than $1,000 5 years later. How much more? We can just plug the information into the PERT formula and it will spit out our total amount 5 years down the road. So let's just plug in our information. A is unknown at this point. P is our principal. That's how much we put in at the beginning. So we put $1,000 in, hoping to see it grow over 5 years. E is the constant. R is our rate, 5%. If I move the decimal 1, 2 place values back, that'd be 0.05, and that needs to be multiplied by the number of years we're talking about, which is 5 years. So step 1, multiply those two values together. Okay, so you can just take 0.05 or 5 hundredths times 5, get your value. That's the number you're going to be putting E to the power of. So if you're not sure what that comes out to, use your calculator to find it. Then you can just say, now most calculators, you're going to hit the second button, and then you're going to hit the button that has the E written above it. Probably a little hard to see there, but you'll find it on your calculators in class. I'm going to put that to the power of, E to the power of. Remember, this came out to 0.25, so we're going to put 0.25 in. Gives me this crazy long decimal. Don't worry about what those values are. Just let the calculator do all the difficult stuff. Whatever we have here, it's on my calculator. I need to multiply that by 1,000. So I just say times 1,000. And what I'm left with is $1,284. And if I round up, 3 cents. So what we get, $1,284 and 3 cents. This is approximately, because that was a 2, but the next digit over rounded it up to a 3. All right, so you put $1,000 into some kind of account that gives you a 5% interest rate by holding that money for 5 years. You're going to have an extra $284.03 in that account by letting interest build. So that doesn't seem like a ton of money, but keep in mind, this is only 5 years, and what we talked about is continuously compounded interest is a long man's game. You want to wait. This is something you should invest in over a long stretch of time, because once it gets growing, man, it just takes off. Okay, so let's just change this information, and this information. Let's do another problem. So I'm going to actually keep it 5 years. I'm going to change it from 5%. I'm going to change my initial value. And what we're going to put in on this one, let's do 500. Interest rate at, what did I say, 10%. Also over a 5-year period. So we're putting in less, but we have a higher interest rate. So we're going to erase the pieces of information that are going to change. Actually, 5 is just going to stay the same, so I should just put that back. 5 years. Interest rate's 10%, so take the decimal that's over here and move it 2 place values back. That'd be 0.1. So times 0.1. My principal, the amount I started with originally, was 500. Again, you're just going to go to that calculator, figure out what 0.1 or 1/10 times 5 is. Once you get that number, put e to the power of that. Okay, so we're going e to the power of 0.5, obviously. Long, crazy decimal. Don't worry about what the number is. Just multiply it by 500 times 500. I got $824.36. This is approximately, actually, it doesn't even need to be approximate. This would be exact. $824.36. So, put $500 in. 5 years later, you gained about $324. Not bad, not bad at all. Now let's see what happens over a long stretch of time. I'm going to change 5. Yeah. Let's go to a long-term investment. 20 years later. Let's change our interest rate to 13%. If you can find 13% interest working for you, go jump on that right away. You're not going to see rates like that anywhere. Well, maybe. We'll see. Okay. And then let's put 2,000 in. Let's put a decent chunk of change in as an investment. So we're going to put $2,000 in. We got just a phenomenal interest rate working for us at 13%. And we're going to keep that money in there for 20 years because I want to have a 20-year celebration. I want a bunch of money coming back to me when I just put $2,000 in at a younger age. 20 years is a long time, right? So this would be something I would highly recommend doing. If you have a couple extra funds, throw it into something that's going to compound continuously over time. You're going to have a pretty good chunk of change 20 years later when you might start thinking about, hey, I want to start going on some vacations now. My life's all figured out and life's going good. Okay, so here we go. We're going to change our information, our principal, P. Try and ask yourself, what piece of information would be your principal? We've done 2 problems. You should know by now that we need to put a 2,000 in right there. We're going to be multiplying it by that weird variable E. That's really just about 2.7. And we're going to put it to the power of our rate multiplied by our time in years that we're going to keep the money in. 13%. 13% is just the same thing as 0.13. So I'm going to change that to 0.13. I'm going to have to multiply that by the number of years we're going to be doing this. 20 years. And then the calculator does all the difficult stuff. You really just have to know where your information goes in the PERT formula and how to do your order of operations correctly so that you get the correct result. Remember, we always want to do exponents before we do any multiplication. Don't multiply this times E first. That's one of the mistakes I'll see some kids do. Okay, so e to the power of 0.13 or 1300ths times 20. So figure out what 1300ths times 20 is. That's going to be 2.6. So we're going to put that to the power of 2.6. E to the power of 2.6. Enter. got a pretty large number there. 13 going to be multiplied by 2,000. Means you're going to get 13 times more money, right? Even extra because it's above 13. Check that out. Take that value, multiply it by 2,000. Put an extra zero on there on accident. Well, look at that. Our $2,000, 20 years later, when we go to pull it out of the account, is worth a whopping $26,927.48 approximately. I did have to round that last cent up just to make it accurate, but oh my gosh, think about the number of Chick-fil-A sandwiches you could purchase with that. Or go buy yourself a new car. There are a lot of options, a lot of things that could be purchased with $26,000, dang near $27,000, when you originally only started with $2,000. Okay, you put $2,000 in. If you're willing to let that money sit for a long extended period of time, you're gonna get a heck of a lot of money back for no work. Sounds good to me. Investments can be key. Now keep in mind, if interest is working for you, this is money coming towards you, that's great. But if you're paying interest, it can really add up quickly, okay? So compounded interest, specifically when it's continuous, you're gonna see growth. And the longer and longer it goes, the bigger the growth's gonna become, okay? Hopefully this makes sense. Study hard and good luck on your upcoming test.